Hey guys, hi, and this time I'm here to start another tutorial series of reinforcement learning analogy. And as you can see here, today in this very first lecture, I'm going to start from a very basic program that how to teach a taxi to pick and drop off passenger at the right location with the help of reinforcement learning. This is an example how we train randomly to an agent and how it perform. While we perform it randomly, there is almost 510 penalties occur and it takes total steps time taken is 1562. Though at this moment I know these terms these terms sounds you weird because you are not familiar with these terms, what is action, reward, policy, state, agent. So let's start from the very basic things, and I'm using in this program the epsilon greedy method to train our agent with. Okay, and in the next following series what you will learn more about and more practical application of reinforcement learning and how you would be able to train your own agent. And okay, here guys, without wasting any time, let me give you a quick overview of theoretical and then I'll move for the practical implementation using gym environment. Gym is a very powerful environment provided by the OpenAI, and now everybody can access reinforcement learning, play, build the program on the top of it. Okay guys, so here I'm giving you an example of reinforcement learning on an analogy by taking a horse training example where the horse is being trained for obstacle race. Okay, I hope you guys are already familiar with obstacle race. If not, then let me open an obstacle race picture for you. Okay, here are some images. Let me give you an perfect example. Obstacle race is something like that. Here, let's say you are the jockey and the horse is the agent. Okay, you are training the horse, and whenever the horse successfully pass the obstacle, you actually pet him and it get rewarded. While if it fails in the reverse, you whip him. The horse is being whipped by jockey, and it get penalty. While if in the successful try, the horse keeps passes the obstacle and finally it wins the race, or in the reverse, it fails some and at any obstacle and start again. So if keeping this as an example of horse training race obstacle, imagine now I'm giving you an overview how you can actually visualize the thing corresponding to reinforcement learning. The horse is an agent that is being exposed to the environment, while the state are the jockey's instructions. Action is done by the agent, and that is jump or run. After jump, if horse successfully pass the obstacle, it get reward, or else it get penalty. The policy is the strategy of choosing an action given in a state of expectation to become better outcome. Now also oh, let me also tell you some basic things about the reinforcement learning. Let me write it down because uh, it is really important. Being greedy doesn't always work, and the sequence matters in reinforcement learning. You know how the sequence is processing. Okay, if successfully keeps on passing the obstacle, it will finally win the race. Okay, not after each obstacle it win a race. For the future better outcome. So reinforcement learning is the science of making optimal decision using experience. There are some process enforcement learning. Observation of the environment, deciding how to get using some strategy, action accordingly, receiving reward and penalty. Learning from the experience and reinforcement learning over the strategy. And later, until the optimal strategy is found, it keeps on learning. So let's move with example, and meanwhile I'll give you some theoretical analysis in between the program. Okay, so here At the very first, you need to import or install the gym environment. You can install it by pip install gym environment, and I'm taking an example of taxi, and that's today what you will learn at the end of this video, that how you can teach your taxi to pick and drop off the passenger from right location. Okay, here we start about the practical implementation. I'm using OpenGym environment, and what this environment contain. Let me give you an overview of this thing also. Uh, the taxi environment for OpenAI gym, you can assume it smart cap. It's, assume you a smart cap is only a vehicle in this parking lot, and this is the parking lot, and we can break the parking lot in 5 by 5 grid, and each grid which give us 25 possible taxi location. We divided it into 5 by 5 grid, and these 25 location are one part of state space. Okay. And notice the current location of taxi is coordinate, it's any coordinates, and in this case as you can see, current state of taxi is 6 6 coordinate. Okay, you will be able to notice that there are 4 location R, G, B and Y. So we can notify these location by 00. This one, this one is 04, this one is 40, and this one is 43 state. Okay, these are the possible location where passenger is being dropped. And also I want you to focus that additional passenger state is being inside the taxi. We can take all combination of passenger location and destination location to come to a total number of state for a taxi. So there are 4 destinations where the passenger can be dropped, and additional passenger which can be inside the taxi. So that means this will fall in 5. So let's say how many total states are possible. So as you know, initially the grid size is 5 by 5. That means 5 multiplied by 5 is 25, which is further multiplied by 5, the all possible taxi location, and there are total 4 locations where the passenger is being dropped. So this is stand for 5 multiplied by 5 multiplied by 5 multiplied by 4. So total state, discrete state can be possible is 500. I'm showing here. Let's move further, and yeah, I would like you to understand the action, just like I was giving you an example of horse. The action can be over either jump or run. So there was 2 actions, and in this case there are 6 possible actions. The taxi can move south, taxi can move north, taxi can move east, taxi can move west, taxi can pick, taxi can drop. So these are the 5 action state which are which is showing here. So these 6 states are south, north, east, west, pick up and drop. And this action space set all action that our agent can take in the given state. Okay, so let's move further, and let's see any state and find out what coordinates it contain and how it's look like. So let me print an state first. So this is the 328th state, and the states, total state contain 500, and this is one of the state where when the taxi are in row 3, column 1. This is third row, first column. Okay, passenger index is 2 and destination index is 0, because nobody has reached in the destination. I can show you all possible state containing in the environment by printing. You can get this file or GitHub. Okay, so these are all possible 500 state available, and each state containing 4 variable. Guys, we were at this point where I was explaining you the action space: south, north, east, west, pick and drop. And then we can encode any state by encoding it using the environment, taxi rows, taxi column, passenger index and destination index by running it. And you can see that this particular state is containing in at state number 328.